Okay, kinematics equations, the big bad boys of kinematics, SUVAT. Don't get confused with what it stands for. S, for historical reasons, stands for displacement. Let's not get bogged down in Y. U is initial velocity, V, final velocity, A is acceleration, and T is time. In all of these SUVAT questions, you will be looking for, in your context of your question, you'll be looking for evidence of some of these 5 quantities that the question gives you. They'll normally give you 3 and expect you to calculate a 4th, and then maybe use that to infer even more information. The 4 SUVAT equations you are given in your formula sheet, but that I recommend you commit to memory anyway, at least everybody's favorite VUAT, V equals U plus AT. Each of these equations uses 4 out of the 5. And so if you've got one unknown, you need to know all 3 of the others. So you need to know at least 3 bits of information, at least 3 out of 5 of the SUVAT quantities in order to use these equations. So the question should always, it might be by implication, they might say at rest or some other means of implication, but they'll always give you 3 bits of information. Okay, that sentence at the bottom more or less saying what I was just banging on about. Each equation contains 4 of the 5. If you know 3, you can use SUVAT to find the other 2. Okay, so write down the variables you know and the one you need to calculate, and then pick whichever of these 4 contains those 4, the 3 knowns and the 1 unknown. So if I talked about implied information, so if the object begins at rest, they often won't tell you like initial velocity equals 0, but if they use the words at rest, you can imply that U is 0 if it begins there. And this can dramatically simplify some of our equations. So S equals UT plus half AT squared just becomes S equals half AT squared. V squared equals U squared plus 2AS simply becomes V squared equals 2AS. Beautiful. Another piece of important implied information is if you're talking about vertical motion in a projectiles question, they won't explicitly give you the acceleration because it's always going to be the acceleration due to gravity, 9.81 meters per second squared. If you're talking about a trajectory where it reaches maximum height, at that maximum height, you can deduce that V equals 0. So they might not explicitly tell you, look, it comes to rest at its maximum height. The fact that it is a maximum implies that it will have to momentarily pause before it then comes back down. Okie dokie. So let's put this into practice. A tennis ball is thrown vertically up in the air with a velocity of 4 meters per second. So that is U given to us explicitly, and is caught at the same height it is thrown from. Nice. I guess that technically implies that's for the total journey, S equals 0. Calculate, there's our command word, the total distance it travels. And so total distance, not displacement. So it wants how far up does it go plus how far down it goes. And those 2 things will be equal. So we really just want to know how far up does it go. So I'm going to park that S equals 0. And it also wants the total time that it's in the air for. Oof. Oof. How mean. It's a calculation question. It asks for a calculate. There's 4 marks. So roughly there should be 4 steps on that calculation. It shouldn't be too easy. If you're getting an answer, immediately, something might be amiss, or you might have to show some more working. And the fact that this is a tennis ball in the air, we can use that we can use two facts. We can use that the acceleration is going to equal g, but also if you're talking about projectiles or something that there isn't an external force acting on it, like, you know, somebody gets a magnet out for a metal ball or something like that, the time of ascent is going to be equal to the time of descent. As long as all the forces on it are constant as it goes up and goes down, i.e. nobody switches a magnet on halfway through, that'll be the case. A useful fact, a useful bit of symmetry to know. So what variables do we know? We know u, we know acceleration, we know it's thrown up and it's going to reach a maximum height, and therefore we can deduce that v equals 0. Sorry, that's supposed to be a circle. Again, as before, we're using the convention that up is positive, therefore the acceleration is negative. Okay, what Suvat equation uses S, U, V, and A? I'm thinking v squared equals u squared plus 2as. Righto. Because v is 0, that simplifies our equation a little bit. We can rearrange for s, plug in our numbers, and we end up with a positive value, good, 0.8154. We are actually only given explicitly u equals 4 meters per second. That is one significant figure. So really we should give an answer to just the one significant figure. However, is that our question fully answered? No, it asks us for the total distance traveled. So that's up and down. Okay, so double that figure. Select the required Suvat equation and rearrange to calculate t. Okie dokie. This is because we are trying to also work out the time taken. Now that we've worked out s, we're actually free to use whatever Suvat equation we like. That includes t. But because it's convenient, let's use v equals u plus at. It's quite mathematically pleasing to the eye. Rearrange for t, sub in your values, and you end up with 0.4077. Lovely. Right. Multiply that by 2. Again, we've calculated the time for it to go up, but we want the time for the